My very dear and loving friends, we are talking on transmission line protection, and we have started with a radial feeder system fed from only one end. That is, on one end there is a source, and then on another end there is a load. In between there will be transformers. So we have seen that the current time discrimination for locating the fault is the best discrimination, in which the time of operation of the relay is inversely proportional to current. Right. So that is the best. And in that also there are two kinds of relays, phase relays and ground relays. As I told, we will talk about ground relays later. First, we have started with phase relays. That is the relays which operate for LL and LLL fault. Ground is not involved. Another thing is that we have seen the rules of flux setting and time multiplier setting for such radial feeder. So now that was only rules, that was theory part. So let us see practically how to set the relay given a system. So we start with an example. Figure 7.8 shows a single line diagram of a power system network. Relays R1 to R7 all are normal inverse IDMT relays. You see, we will see that there are very inverse, extremely inverse, and actually in the modern numerical relays, there are 17 different types of characteristics for IDMT relays. Let us not talk about too much now. Right now, we agree with normal inverse relays, simple relays, IDMT, but right. The maximum power flowing in transmission lines is tabulated in figure such and such. This power is calculated considering 10% overload. So you have not to consider 10% overload now because it is already considered. TMS of R7 is given 0.1. You have to calculate flux setting and time multiplier settings of phase relays R1 to R7. And also you have to calculate the setting of high set instantaneous inbuilt with relay R1, given that percentage overage of high set unit is 10%. This is our example. I mean, this is what we have to solve, right? So let me go to figure first so that you may come to know. This is my figure. This is my network. Portion of a power system network. 3 generators, 15.75 kV, 210 megawatt, 0.85 PF. 3 GTs, generator transformers, 15.75 by 220 kV, 250 MVA, DY11 each. From there, here it is shown that 3 lines are emanating, and out of that one line, 220 kV line is there. On that there is a CT 1000 bar 1, and across that there is a relay R1. That is normal inverse IDMT relay. I have talked and I will again and again remind that this is a single line diagram. Means R1 is a bundle of 4 relays, 3 phase relays and 1 ground relay. Right? Even if numerical relay is there, the casing is 1, but the settings are different for phase and ground relays. So there are more relays than 1, but here I am showing 1. Then I've got bus. I've got bus B. From B to C, I'm stepping down because now the economical voltage is not 220 kV, so 220 to 132, 250 MVA, right? DY11 transformer. That takes me to C. On both sides of transformer, there are relays R2 and R3 fed by series 1000 by bar 1 and 500 bar 1. From C, we are coming to bus D via 132 kV line. At the start, there is a relay R4, which is fed by 500 bar 1 CT, and at D there is a relay R5, which is fed by relay. Which is fed by CT 500 bar 1 relay R5. Then now once again 132 kV is not economical, therefore I step down to 66 kV. The relay R6 is fed by 1000 bar 1 CT. Then there is bus E. From there, 66 kV feeders are going. 166 kV feeder has got 300 bar 1 CT ratio and it feeds relay R7. That takes me to 66 by 11 kV distribution substation. I mean, I can yet have that distribution transformer and 11 kV feeder. I can lengthen this example as much as I want. But let us understand how we can set relays R1 to R7 critically. That is what we would like to see. Now for this, what is given is this: the power in AB and in CD lines, you see, is given. Let's see. Power in line AB 220 kV line is given 197 megawatt at 0.8 PF flag. Power in CD means 132 kV line. Power is 132, 66 megawatt at 8.8 PF. And power flowing in 66 kV line is 22 megawatt. 66 kV line is this 22 megawatt at 0.8 PF flag. So this is given. So going further, you must know the fault current also to calculate the time multiplier setting. So triple line fault and double line faults. Again, we are not talking about ground yet. So only triple line and double line at different buses. Values are given. You can see that. As and when it is required, we'll refer to this slide again and again. So now we have to start with solution. And as you know, in such radial feeder, you always start with the last relay because that is going to operate first. And the upstream relays are going to give backup. So we'll start with R7. PS of R7 is based on rated full load power of 66 kV, which is given as 22 megawatt. And it is 66 kV line. So if you calculate the current, it is 240.56 ampere. And if you want to find out the plug setting, 240.56 into 100 divided by 300, it is 80.18. And because I am going according to old relays, 50 to 200% in steps of 25%, no doubt. In between, I have given a slide in which I have considered 80% also, 81%, 82% also. That is possible in numerical relays. But here, I have to go for 100% only. PS of R6 will be dependent on maximum power through 132 kV line. See, PS of R6, let me see. PS of R6. PS of R6 is dependent on maximum power considered 132 kV line because that power is flowing through R6. Whatever 132 kV line takes is flowing through R6, no doubt on 66 kV side. So you have to consider that. So you see, that's what I'm considering. What I'm doing, plug setting of R6 is, it is plug setting of R6 will be dependent on maximum power transfer through 132 kV line. So that maximum power transfer, what is the maximum power transfer? Let me check up. It is 66 megawatt. So 66 megawatt into 10 raised to 3 into 66. Right? Because my voltage there is 66 kV. Right? And 0.8 is the power factor. So I come to 721.68. And my CT is 1000 bar 1. So 72.16. So plug setting of R6 will be 75%. Right? So 50 to 200% in steps of 25. Let us check up the coordination between R6 and R7. Just for the sake of checking, every now and then this is not necessary because if you come to know that this is going to be lower, then you need not worry. See, PS of R6 was 100%, and 100% means 100% means, let me see. R7 is 100%, that is 300. So 300. So if I consider that 300, so 1.3 divided by 1.05 of 300. So that takes me to 371. 0.43 ampere. And that is a percentage of 1000 is only 37.14. So that way I have to calculate, I am coming to only 50%. So 75% is certainly more. So 75% for R6 is correct. 25% for R6 is correct. Similarly, PS of R5. R5, what is happening? Nothing else. R5 is backing up R6. So 1.3 divided by 1.05 of R6. That's what you have to do. So that is what is done. PS of R5 is 721.68, right? Into 66 divided by 100. That gives me 72. That means that gives me 75%. But if I consider 1.3 divided by 1.05, then 1.3 divided by 1.05 into PS of R6, which is 1000 times 0.75 into 66 by 132 gives me 464. So 464 gives me 92.85%. So 92.85 is more than 72.168. Therefore, I will consider here 100%. On the same line of calculation, PS of R4, you can calculate 125%. PS of R3 will be dependent on power flowing through 220 kV line. Power flowing line is 197 megawatt. So it is 71.8. Therefore, I will consider 75%. But I have to see that R3, R4, 1.3 divided by 1.5 also. That takes me to 773, and that is only 51.58. So that way also it is 75%. So 75% for R3 is correct. PS of R2. PS of R2. What is R2? Let me check up. What is R2? What is R2? PS of R2 is 1.3 divided by 1.05 of R3. Right? That is only. That is one thing. But that is not the thing because other lines are going. Therefore, it will depend on 220 kV line and also 1.3 divided by 1.05. So let me see what we have done. PS of R2. PS of R2, what we have? PS of R2, 1.3 divided by 1.3 divided by 1.05, 132 by 220, that is transformation ratio. And R3 is 75%. So 1500 bar 1 is the, 1500 bar win. Let me see at R3. 1500 bar 1 at R3. At R3. At R3 50. Sorry, at R 500 bar 1 is there, not 1500 bar 1. R3 is 500 bar 1. So why there is 1500 bar 1? 1.3 divided by 1.05. 6 197 into 10 raised to 3 into 100 root 3 132.8 divided by, I have taken 1500. How have I taken 1500? That we have to see, because that can be a CT ratio, because 197 into 10 raised to 3 root 3 3.8 is the current. So R3, that means R4 I have to see. That means I have to see R4. R4 is that is I'm checking for R1, right? So what is the plug setting of R2? The plug setting of R2. Let me check out what is the plug setting of R2. R2. Plug setting of R2. Plug setting of R2. I have to yet check. I have not done. Plug setting of R2 shall be set at 100%. and 100% is I have taken 50 R to 1500. So at one point there is a ratio 1500. So there is some typographical mistake in these ratios, right? Because this is 1000 bar 1, therefore at R5 it is 500 bar 1 seems to be correct. At R4 also 500 is seems to be correct, but at the point R3 it must be 1500 bar 1. So at the point R3 there is an error at the point R3. There is an error at the point R3, and if I calculate the flux setting of R3, flux setting of R3 have I calculated? Where have I calculated flux setting of R3? Flux setting of R3 220 kV line. So flux setting of R3 1500 ratio. So R3 is not 500 bar 1 but 1500 bar 1. Please correct that. R3 is fed by 1500 bar 1. So that comes to be 75%. So for R2, 1.3 divided by 1500 of 0.75 into 132 by 220 transformation ratio, and 1000 bar 1 is the CT ratio. So there PS of R2 is 100%. And on the same line of calculation, PS of R1 shall be set at 125%. So like this, you can set the plug settings, critical plug settings. So while you are deciding the time settings, you will have to coordinate two relays, right? So when I am deciding time setting, R6, R7 I am coordinating. Try to see. I am coordinating R6, R7. R6 with R7. That means I will take the fault at bus E because fault just after the breaker and E is same. So maximum fault current for fault at bus E. Maximum fault current is 2880. So I am taking 2880 for time setting. Alright, let me check up. 2880 I have taken. 300 is the and 100% was the flux setting. Therefore 9.6. Now for time of operation, there is a mathematical approximation for normal inverse only. Yeah? For other relays, very inverse, extremely inverse, the formula is different. But for normal inverse relay, the easiest formula, easiest mathematical approximation, because you see every now and then you cannot refer to the curve. So 3 upon log 10, 9.6, that is 3 upon log PSM into TMS. So that gives me 0.3054. So top of R6 is 0.3054 plus 0.25. I have to add 0.25 time discrimination, which we were talking yesterday. 0.5554 second. So now I have to consider PSM of R6 for the same current 2880. So that gives me 0.75 3.84. So 3 upon log 3.84 into TMS, which is not known, is equal to time is known. So from there I will come to know TMS 0.108. But if I go in steps of 0.05, then I will take TMS of R6 as 0.15. R5, R6 coordination also, fault current is the same. You can see for R5, R6, fault current is the same. R5, R6, fault the same. R5 and R6, fault current is at bus E, same, right? So 2880, that there's no difference. So like this, you have to go on referring to fault current. So R5, R6, fault current is same 2880. PSM of R6 is 3.84, does not vary. But top varies because top is not now. You have decided the time of operation, I mean TMS 0.15. So based on that, top of R6 is 0.77. Top of R5 0.25 second more. Based on that, TMS of R5 will be 0.2. Then that TMS of R5 will be 0.2. Every now and then you will have to see that if transformer is there, transformation ratio you cannot forget. So R5, R6 I have coordinated. Then I have to coordinate R4, R5. For that the fault current is 2146. Let me see R4. R4, R5, R4, R5, R4, R4, and R5. That is at bus D. Bus D. Bus D is 2146. Yes. Bus D is 2146. That is 2146. I am going for 2146. Yes. So I am going for 2146. 2146 ampere. PSM of R5 is equal to 4.292 for this fault current. Time of operation 3 upon log 10 PSM, if you calculate, it is 0.9483. Top of R4, 0.1.198. You know the time, but you do not know the TMS. TMS can be calculated 0.25. On the same way, TMS of R3.2, R2.15, and R1.2, you have to simply, you can repeat yourself. You can do the example for yourself. Setting of high set unit of relay R1 is 100 B over 100 minus A. What is B? B is maximum current at point B. So maximum current at point B. B 3017. 3017. 3017 you have to take to secondary. 3017 you have to take to secondary. 3017 I have take to secondary divided by 1000. So 100 into this divided by 100 minus 10, 90. 3.35, 335%. Therefore, I should go to 350% if 50% steps are given. If 100% steps are given, I have to select 400%. So this is how the time settings, TMS, can be decided. You see, this setting is a very critical exercise. If you do wrong settings, then there will be many mal operations and many damages to the system. Therefore, protection is a very critical subject. We are summarizing the settings what we have done. R1 125% plug setting, R2 100, R3 75, R4 125, R5 100, R6 175, R7 100. TMS R1 R7.1 given, R6.15, R5.2, R4.25, R3.2, R2.15, R1.2. So like that, this is just a summary of what we have done. With that, my dear friends, I come to an end of this example. This was just an example. Many such examples can be solved. That is available in module 3 of AdaptMe. But for that, you will have to download AdaptMe from Play Store, open AdaptMe, go to engineering subjects and go to power system protection. You will have to pay for that. And then there you can get all these things. Plus, you will get questions and you will get different numericals so that you can be master in this subject. So numericals, many numericals cannot be given in this video tutorials which I'm floating on YouTube. So my dear friends, I've been keeping on telling to you that my target is 4,000 viewers, which is I think only 1,000 as yet. 4,000 I want to see by the end of this month, that is by the end of June. But that depends on you because I cannot do alone anything, right? So my viewers have to share to as many friends as possible. They have to tell everybody that you read through these things. This is very important. And I'm sure, my dear friends, this is not taught in universities. I do not have any experience of foreign universities. No doubt, at least 2 or 3 fellows from foreign, from Ghana, from Indonesia, from Malaysia, from Pakistan have told me that, sir, these things we have not learned in university. But at least in Gujarat, I know that this is not taught in my state of India. And I think it must not be taught in India also, all over India. many reasons, time restraints, right? Staff, faculty restraint. Faculty does not know the subject, right? Uh, Faculties are given so many administrative work that they are burdened with many other things and they cannot teach nicely. I mean, innumerable reasons. I do not want to go into that. But I've started disliking the educational institutions now because they have to depend on uh, the central bodies. One of the government engineering colleges in Gujarat state had applied for SCTP, short-term training program of 1 week. The approving authority said that we are approving only once in a year and that we are doing in August. But that approving authority does not know that experts whom we are calling, you are insulting those experts. Experts will not come as per your wish. Experts will come as per their wish. Expert do not come according to wish of the government. Expert will come according to, because that is the reason why they are experts. I am expert. In Vadodara, there is one expert I know. Right? If you go and say that I want to ask a question, then he says put rupees 5,000. For asking a question 5,000. Forget about answer. You are allowed to ask the question only if you put 5,000 on the table. पहले 5,000 रुपया रखो, you put 5,000 on my table and then you can start asking a question. Yes, now start. The person completes the question. Yes, I will give you the complete solution of your question within a year. The fees is 1,50,000 rupees. This is expert. And government says one institute has decided in July 13 to 20. I'm continuously asking because I have to take maximum number of classes. The person says that the approving body says that we will do it in August. So by this autocracy, आप खुद सही से कुछ काम होंगे नहीं, हमें अपने आप करने होंगे. If you are in the private organization, it is not like that. Private organization, things are done very fast. I was in Baroda Electric Meters. My boss used to tell to me that I want the work yesterday. If I ask him, he will give me the work that Oza, you do this work. And if I ask him that when do you want me to complete this work, he says that I want this work to be completed yesterday. एक अगले दिन हो जाना चाहिए. I mean, that is the emergency. I think that's a joke, but that is the emergency. So, my friends, forget about all organizations. Don't depend on organizations. Organizations have their own inertia, and because of inertia, they are very slow and they are not acting. Probably by the time that governing body will decide that yes, you can arrange the ICT, by that time 3 experts would have died. 3 एक्सपर्ट तो मर गए होंगे. तो ये काम ऐसे नहीं चलता. तो प्लीज फ्रेंड्स, this is individual effort. Adapt Me is working on individual effort. If you have faith in me, you share to many more number of electrical engineers and request them to read through the videos, hear through the videos, so that I earn more and more viewers and more likes. Yes, friends, I'm sorry I have become little hot because I dislike the pattern in which, because I have studied in the era when the educational system was different. I am 72 years old now and I have graduated in 1972. So I have studied in an era when the education was very strict. Now the teachers have to, students are strict and teachers have to follow the students. So things are different now and in that I cannot survive. So I am leaving the education up till now, up till yesterday I should say. Last semester I was serving once a week 2 institutes, but I'm going to discontinue because students don't want to learn. They say that with the stamp of Nirma or PDU, they will go to USA or UK. There somehow they will learn and they will earn money. That's all. So why you are so much behind protection? Because we are going to go to computer science. Computer science is the latest thing. We are going to computer science and IT when we go to foreign countries. And they are allowing electrical engineers to go to computer science and IT. So our system protection is only useful to industries in India who are connected with direct work with machines and transformers and this and that, motors, etc. And they want to protect things and they are facing the difficulties. And when they are facing the difficulties are solved by concepts only. Difficulties are not coming from anywhere. There I have solved many industrial problems just conceptually. Just conceptually. So, friends, thank you so much and good day. Thanks for patient hearing.